When you start such a project as this, say a very simple oscilloscope, and by the way, this is only a vlog. I don't show the definite schematic because it is still under construction. I will tell more about that anyway. When you make a mistake in the very first stages of such a project, that will go on and on and on, and doing experiments, etc., etc. So I made a small mistake in the beginning of this project, and that was that I reversed the horizontal and the vertical plates. That was a serious problem because I made a horizontal amplifier, and there was defocusing of the dot. When the dot moved from the left to the right, it defocused. That has everything to do with, say, also the static voltages inside such a tube. And after many experiments, my idea was, well, let me change the horizontal and the vertical plates. And that proved to be okay. And when I studied the data sheet of the tube in a better way, I found that that was the solution. So in the very first video, I made a mistake by indicating the deflection plates in a reversed way. So this is my drawing of 1 October 2022. Here are the plates again, and now here is the correct indication, the correct numbers to the tube socket, etc., etc. Anyway, at the moment I don't want to give the schematic, the definite schematic of this very simple oscilloscope. I only will tell something more about what happened during the past days and during all these experiments. When you are interested, perhaps this is a good overview of the tube. Anyway, so it is the horizontal amplifier. It is in fact a Darlington made with 2 high voltage transistors. I will tell the type numbers in the description. They can handle approximately 400 volts. They are switched as a Darlington, and they are driven out of the sine wave, not the sine wave, the sawtooth wave generator, that is thus the time-based generator, and they are driven via a potentiometer of 1 kilo ohm, and that's what you see here, the horizontal drive. And that potentiometer gives, say, a very precise voltage to the basis of the first base of this Darlington. So now I turn that here. Let's see what happens. Looks like the frequency goes up, and here you can see that you can drive the Darlington via that voltage out of the sawtooth generator. That's a time base. Well, switch off all the lights. Perhaps that it makes it more interesting to see what happens. Anyway, here is the 10K resistor. The 10K resistor is connected to the power supply, 280 volts approximately, and these transistors can handle that. And because it's a Darlington, it's driven by tiny currents, and these tiny currents are coming out of the sawtooth generator alias time base. So let's go to a higher frequency here in the time base. Of course, now we don't see the dot, so move here in a quite low frequency way, but we will see here a line. Perhaps interesting to tell, I had to remove, and of course I knew it from my earlier experiments, I had to remove the transformers completely out of the room of the oscilloscope tube, because they hindered the waveform on all kinds of frequencies. So here's a transformer, here is another transformer, etc, etc, and there's a very high voltage here, 700 volts, so a little bit dangerous anyway. So moving all these transformers far away from the tube got the result that the line here, horizontal line of the horizontal amplifier, was no longer disturbed. So you can see it here. No longer. It's a quite good, pure, straight horizontal line. Also only here on that low frequency we see some disturbances. Anyway, well, let's go to a somewhat higher frequency. The only problem now is that the horizontal amplifier here is not moving the dot completely. It's moving the dot over the screen, but not completely from this position here outside of the face of the tube to the right side in the outside of the face of the tube. So I am absolutely sure I need a higher supply voltage to drive the horizontal amplifier in a better way. Anyway, that was more or less all. Important to tell, here you see these white cables, and these cables are shielded. I found out, and I found that also out when I made another oscilloscope in the past, that no sloppy wiring, that's not okay. So now the plates are connected via these shielded cables, and here the cables are not shielded to the front of the oscilloscope, but I'm gonna use also shielded cables here to bring the distortion of the dot on the screen to its absolute minimum. That was a serious problem, and also the reason why I made this completely other setup. The transformers were, say, removed as far away as possible from the oscilloscope tube. Both this transformer and that transformer, etc., like I told. So now we have a quite good horizontal line, and it also works quite good. Here you see some distortion, say not distortion, but an effect on the horizontal movement. Anyway, now we go to position 2, that is 6 Hertz to 24 Hertz, and now we are on position 3, let's go to 4, 0.5 Hertz. And here there is a kind of problem that I have to encounter.